Welcome to the whitchermath channel. Wake up! Here we go. Short and sweet. Today we're going to talk about scale factor, corresponding sides, and similar figures. The stuff you're learning is in black. What it's called is in red. Done. There we go. 3 visual examples. Wasn't that nice? Now, if you need a little more detail than that, please continue watching. We have 3 objectives today. The first one is we're going to define scale factor because we can't use it correctly if we don't know what it is. Functionally know what it is, like not just the dictionary definition, but how it works and what it means. Then I'm going to leave some room there because we're actually going to define it. Then we're going to, if I give you similar shapes, similar figures, we're talking 2 dimensions here, flat surface. If I give you similar figures, you'll be able to find the scale factor. That'll be cool. And you'll also be able to find unknown sides. Unknown sides in 2 different ways. Either I give you the scale factor or I don't give you the scale factor. Okay? Don't worry, you can do it either way. Don't worry. Okay, and finally, our third thing today, we're going to test for similarity. That's the shortest and easier thing. Easier, I don't know. I just got back from spring break, so you'll have to excuse any speech or grammatical errors I make, but hopefully the content doesn't get mixed up. Here we go. First, we're going to define scale factor. Simply, if we look up here, scale factor is when we're dealing with 2D shapes, 2-dimensional shapes, flat, right, on paper. It is a ratio written as copy on top of the original, written as a fraction. Copy on top of original, right? It's a multiplier. A simplified ratio. It's a multiplier that connects 2 shapes or more. Okay? So, for example, up here, if I have, this is 2 and that's 1, and I say, what is the scale factor? What's the multiplier? If this is the original and that's the copy, well, it's quite simple. Copy goes on top of the original, right? So, copy was 1, original was 2, scale factor is 1/2. That is how it works. You need to know what the original is and the copy, okay? Or else you only have a 50% chance of getting it right. So, there we go. So we define scale factor. It's a simplified ratio. It's a ratio written as a simplified fraction. That is the multiplier, copy on top of original, that connects 2-dimensional shapes. Now, next thing, given similar figures, find the scale factor. We'll get to that in a second, okay? Let's work a little more on defining scale factor. What is it? Well, first of all, remember we need to know original and copy. Okay, on this case, I've got 2 and 4. I'm just labeling the corresponding sides. Those are the sides that match, right? There's 3, and this one is 6. So what is the scale factor here? Well, you can compare any pair of corresponding sides. Copy on top. Copy on top here. What happens if I simplify either one of those? I get 2/1 or simply 2. Okay, so remember to simplify, because if you found 4 over 2 and your neighbor found 6 over 3, but you both simplified, then you both got the same scale factor. So you must simplify it, okay? Let's look at this next example. Looks like we got 3 here and 2. What is the scale factor? This is the original. This is the copy. Well, quite simple. Put the copy on the toppy. Oh my. Oh my.
It's time for technology round 2. If you'd like to come to March
There's an announcement.
E9, Susan Bernard and I are going to be hanging out there.
Oh, announcement. That's long enough.
And we're also going to be spending some time working with people on anything you'd like to learn about iPad apps.
Boo doo 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 boo doo doo doo. That was a long announcement. Okay, I'm going to keep going. There. Can that be simplified? No, so that's the scale factor. Okay, remember, copy on the top. And finally, this one here, well, there's 1, there's 1, there's 5, there's 5. It's the same, right? That means it's congruent, same size, same shape. Look at all these S's. It's an S convention. There we go, same size, same shape. You might say, well, that doesn't have a scale factor. Wrong. Scale factor is 1, right? Because if I make a ratio out of all the pairs of corresponding sides, right, and I simplify them, what do I get? 1. There is a scale factor. Okay, so the lesson here is there's 3 types of scale factors. And they cause 3 different things to happen. If it is less than 1, the copy is smaller. If it's greater than 1, what is it? The copy is bigger. And don't be fooled. This is not a trick question. It's just a question. It's only a trick if you don't know it. If the scale factor is exactly 1, it's the same. Nice. Okay. Now let's move on here. Let's go back to our objectives here. Did we hit it? Do you think you know what scale factor is? I don't know. This is a short and sweet video, so who knows? Well, let's move on. Let's do a little practice. All right. Just pause the video and do these real quick, okay? I'll give you 10 seconds. And go. 1, 2, 3, 4, 5. You can do this. You got it. There's no pressure. You can do it. 10. Woo! 10. That means done. Okay. What is the scale factor? If this is the original and that's the copy, first we have to find corresponding sides. That could be kind of tricky. That one matches that one. That one matches that one. The thing is, if I just go copy on top of original and copy on top of original and simplify them both, what do I notice? They're the same. 1/2. Is that what you got? Hey! Nice. This one here, we need corresponding. It's like a little matching game. If you spin it around and make them the same size, which numbers would match? Okay, if we go copy on the top, copy on the top, copy on the top, but simplify them, what do you get? 2 over 1 or just 2? Is that what you got? Of course it was. And notice this. Less than 1 made it smaller. Bigger than 1 made it bigger. More practice. Let's find the unknown side. Okay. Well, if I'm going from 12 to 6, copy on the top, simplify it, my scale factor is 1/2. So I'm just going to take 10. What is half of 10? Right, it's 5. X is 5. Next, I'm running long. I'm freaking out here. This video is over 10 minutes. You're not even watching anymore, are you? Oh, okay, I'm nervous now. Okay, there is a corresponding side pair. 20 over 8 equals what? If I simplify it, 10 over 4, 5 over 2, or I could say it's 2.5, right? Okay, so if I work backwards, something, oh, look at this. 2.5 times something equals 12.5. How about 5? Hey, did you get 5? Okay, and finally, let's wrap it up. Are these shapes similar, yes or no? For them to be similar, they need the same scale factor, right? So, let's match up our corresponding sides. What's our scale factor here? 2.5. So that is a yes. What about this one? 2 times 2 is 4. 4 times 2 is not 6. Those do not have the same scale factor, so they are not similar. Wow, we had a lot going on in this video, but let's take it back to the basics here. Lots of pretty colors, and our whole goal was to learn through defining, using examples, what is scale factor. Did we do it? That's for you to decide. I gave it my best shot, though. Thanks for watching Whitcher Math, and stay tuned for more exciting math videos.